Each group has 2 springs in their toy boxes. The springs are a certain length to begin with, but we can do work on them to stretch them. In their stretched state, they have potential energy. Our goal is to come up with a mathematical model for the elastic potential energy in these springs. We will hang the springs vertically and measure their lengths as we hang different amounts of mass from them. Get 5 data points for each of the 2 springs. The weight of the mass will stretch the springs. Based on how we will collect the data, what are the independent and dependent variables for this experiment? Since we're adding weight on purpose and then checking the stretch, we would assume that weight is the independent variable and stretch is the dependent variable, and that is true. But all the other work graphs we have drawn so far have had distance on the x-axis and force on the y-axis. We will do that for this lab also. The springs are purposely misshapen. The springs we are using are purposely misshapen. The top and bottom coil are bent so we can use them as hooks. We will define the length of the spring to be the length of the barrel of the spring, not including the bent hooks. To take data, we will hang a spring on a lab stand. We will use these slotted brass slugs and add weight to the spring. To attach the slugs to the spring, we will use this mass hanger. Note that the hangers we own have a mass of 50 grams all by themselves. That value should be included in your measurements. The easiest way to collect the data we want quickly is to record the mass that you are hanging in grams and then record the overall length of the barrel of the spring in centimeters. This raw data will need to be changed before you make a graph. Switch your masses in grams into forces in newtons, and switch the lengths in centimeters into stretches in meters. Once you have reformatted your data, you can make a graph that shows both springs together. For each spring, I want you to calculate 3 things. First, get the slope of each line. The symbol for the slope is a capital H, which represents the elastic constant for the spring. We use an H because this experiment was originally done by a guy named Robert Hooke. Get the equation of each line. Start with the linear model, switch the letters to better letters for physics, adjust the significant figures appropriately as well. Lastly, compute the areas under the graphs. This will represent the work done in stretching the spring and the elastic energy contained in the spring when it is stretched. For your check, compare the slopes of your 2 springs to each other.